Hello everyone. Today we are going to discuss about OWASP Top 10. The Open Web Application Security Project is a non-profit foundation dedicated to improving software security. Basically, the OWASP Top 10 is the top 10 vulnerabilities on the web application provided by a non-profit organization. So this list is released or developed to help the developers and the security team to overcome with this top 10 vulnerabilities on the web application. And this video is all about to get a basic understanding of top 10 vulnerabilities of the recent list 2021. So this video is having top 10 vulnerabilities of the recently released OWASP top 10 list in 2021. So the first, broken access control. One more thing, this video is not having deep discussion of those vulnerabilities. It is just to have the basic concept of those top 10 vulnerabilities and some examples and how to prevent them. So first top 1 web application vulnerability is broken access control, in which a user can access, modify, delete, or perform actions outside the limit of permissions provided for that user. In this vulnerability, let us imagine a user U1 is accessing a file called homework or a office file. It should not be accessed by that user U1. Let us imagine a user U1 is accessing the office file. So the permission is not given by the admin for that user U1 to access that office file, but still he is accessing. Then the token access control comes into picture, where a user tries to access the data, performs these actions which are not permitted to that user, which are not assigned to that user. So that there comes the token access control in picture. So we can take an example of bypassing access control checks by modifying the URL. Attacker or hacker can get the unauthorized access by bypassing the URL check, permitting, viewing, or editing someone else's account. Hacker can do if hacker do or modify or able to access someone else's account, which is not belonging to that user. So that also comes in broken access control. And acting as an admin when logged in as a user. If a user performing the actions, performing the viewing the data or modifying the data, it should be accessed by the admin. So that is also some broken access control. So how to prevent it? So for this, prevention measures, preventions are: except for public resource, deny by default all other sources. So whenever an admin is making some policies, so except for the public resources, all other resources should be denied by default. Having the preventions are just to understand the broken access control. It's not having deep prevention, just to understand how to prevent this broken access control at a very basic level. Okay. So admin can deny by default. Admin can make a policy to deny by default all other resources which are other than the public. Okay. And report admin for repeated login failure logs. We should make a policy where admin get report where someone is trying to access more than 2 or 3 times. More than 2 or 3 times failed login, can a broken access control can be done to get the broken access. Second vulnerability is cryptographic failure. In this, this is vulnerability where security of data will fail and which exposes sensitive data to read a non-authorized user, by a non-authorized user. In this cryptographic failure, the security for the data will be failed. Like Let us imagine we are transferring a data, okay, encrypting it from our side, and someone is weaving in between in between before reaching to the destination. Like a hacker is sniffing our data, so that leads to cryptographic failure, where our privacy to our data will be not remain. So usually that will happen. The examples of cryptographic failure are data transmitted in clear text, any old or weak cryptographic algorithms or protocols, weak crypto keys or crypto keys generated or reused. Usually cryptographic failure happens whenever, let us imagine a user is using only a website by using HTTP protocol, where the data is transmitted in plain text. So the privacy for the data will be not there. Or any old or weak cryptographic algorithms or protocols which are using. Let us imagine a user using the cryptographic algorithms which can be hacked, which can be decrypted by a unauthorized user, and weak crypto keys generated or reused. So by using the already used cryptographic keys to encrypt our data can also lead to cryptographic failure. So prevention for this cryptographic failure are using asymmetric encryption, make sure encrypt all sensitive data at rest, ensure up-to-date and strong standard algorithms, protocols, and keys are in use. So for this cryptographic failure, the preventions are by using a asymmetric encryption, where for encryption for the encryption of data, a different key is used, and for the decryption of the data is different key is used. So for the both encryption and decryption, the different keys are used, and we have to make sure that the data at rest, wherever we are storing the data. Let us imagine we are storing a data in a server, and that also have to be encrypted, because the data is encrypted only while traveling through the internet. So when it reaches to server back, when it reaches to the server, it should be encrypted before storing in the before storing in a directory or a bucket. And we have to ensure that we are using the up-to-date encryption encryptions which are up to date. We should use the updated algorithms, protocols, and keys. So next vulnerability is injection attack. In this, hacker injects a malicious code, query, or command to the web application to get unauthorized access. In this vulnerability, an attacker or a hacker injects the command, query, or a code to website or a web application to get the unauthorized access, where the hacker runs a command which should not be run and should be filtered from the application side. Application should be filtered by application. So that will lead to the injection attack. Okay. Attack can happen when user supplied data like query, command, or program was not validated, filtered, or sanitized by the application. Usually, the injection attack happens when the web application security is not having that much capability to filter the commands or queries or code transmitted by the user, because we cannot trust anything outside of our network. So, web application should have capability to filter those commands before receiving it, and allowing user to execute command queries which are not in their limit of permissions given to a particular user. So it also fails. It also injection attack can also happen when a user able to run the command or run the query which is not permitted to, which is not in his permission limit. So we should restrict the user to not to run those commands or queries which are not in their limit of permission. So we can prevent them by filtering, validating, or sanitizing the input data of a user's application. So we can prevent injection attacks. Before we can prevent the injection attack, filtering the queries, codes, or commands which are run by a user uh, before receiving it at the server side. So we should filter them, we should sanitize them, and then only we have to accept those commands and queries. We can design. So next vulnerability is insecure design. In this, developer, QA, or security team fails to meet or evaluate parameters of security during code design. So insecure design is the where a developer or a QA or security team fails to meet the parameters of security while developing the web application. So prevention for this is restricting the resource consumption by a user or service. We should provide very limited access to the resources for a user or a services. We can protect our data by providing very limited access, very limited resource access for a normal user or a normal service. Check for possible critical vulnerabilities from front end and back end at each tier of system. And next vulnerability is security misconfiguration. So security misconfiguration, okay, security controls that are not secure or misconfigured. This is vulnerability where the security configurations are not done well, where a security admin or the security team fails to do security parameters, to set the security parameters, or to do security configuration, to do well security configuration. Okay. And some examples for security misconfigurations are default accounts or passwords are enabled or unchanged, lacking security hardening in any part of an application, wrongly configured permissions on the cloud services. So most of the cases, security misconfiguration will lead when a security admin is not in the default username and password. We can see there are some many routers which are using the default username and passwords. So that can be lead to misconfiguration, security misconfiguration, or wrongly configured permissions on the cloud services. When an admin given the higher privileges for a normal user can lead to the security misconfiguration. Okay. And prevention for this is keep software up to date, change the default password, rectify wrongly configured permissions. So vulnerable and outdated components is the next vulnerability. So vulnerable and outdated components vulnerability will occur when in our network, in our environment, IT environment, when we are using the components which are not updated and which are outdated and which are already having some vulnerabilities. So using components with known vulnerabilities and using old components which are not having patches can lead to vulnerable and outdated components vulnerability. Some examples are like when we not update for given patches, if you are not aware of which version of softwares are using at client and server side. Preventions for this are keep software up to date, remove unnecessary components which are not in use. We can eliminate this vulnerability by removing the components which are not in our use, which is we can replace those components. If you are able to replace 2 or 3 components instead only one, so then we have to remove those two or 3 components, and we have to use only one single component if we are able to do that, which can lead to more security than we are having more components. So next vulnerability is identification authentication failure. These include vulnerabilities, related application authentication, and identification skills. In identification and authentication failure, the security teams are where the where fails to identify the unauthorized user or the hacker. If we are able to identify the hacker, we can easily provide the protection to our authenticated users. So in this vulnerability, security team or identification authentication uh, security fails to identify and authenticate a unauthorized user. So usually this will happen when allowing brute force attack and dictionary attacks, not apply strong password policy, allowing to use default or weak passwords. So these are the most common cases where identification authentication failure occurs, like allowing to perform brute force, dictionary or hybrid password cracking attacks on a web application can lead to this. Using default passwords, using weak password policies can lead to the identification and authentication failures. Prevention for this is to preventing those brute force attack and dictionary attacks. Add two-step authentication methods, block dictionary and brute force attacks. Strong password policies can provide security to can provide overcome with this identification and authentication failures. So next vulnerability is software and data integrity failure. This includes vulnerabilities of software and critical data whose integrity was not verified. We can say that when the data is stored in a place, it should be remain same till accessing by a authorized user. So software and data integrity failures occur, which is changed before accessing by a authorized user. That leads to software and data integrity failure. Examples are like known vulnerabilities of software, when auto update softwares are not tested, preventions like use a software supply chain security tool to make sure that the components do not have any known vulnerabilities.
The next vulnerability is security logging and monitoring failure. This includes failure of logging, monitoring, and detection of vulnerable events. This vulnerability will occur when a security team in an organization or a Splunk team, the one who is managing the security events, fails to get the logs against the vulnerable events. Like someone is trying to access, someone tried a brute force attack on the um, organization machine, so the event against that is not generated or not monitored properly or not detected in the log events, so that leads to security logging and monitoring failure. Examples are like when critical events not detected or not monitored properly. Prevention for this is to make sure that logs will be in form of that can easily be understand, and using logs can easily detect the malicious activities. Make sure logging of critical events were not missing. So these are the prevention that can be taken against the security logging and monitoring failure. And the next vulnerability is server side request forgery. This occurs when application is fetching remote resource without validating user applied URL. So this vulnerability occurs when the application server side um, not filter the requested URL. When a user requests a URL, it should not be access the privileged directories of the web application. So uh, user requests that some privileged directories of the application to get access, and application fails to prevent that. Okay, and prevention for this is sanitize the URL or use or user supplied data.